So this algorithm here, labeled base conversion, tells us what to do step by step to convert something from base 10 into either, well, into any base you want, but in particular into binary, octal, and hexadecimal. So here's what we do. You divide n by b to get a quotient and a remainder. Remember the division algorithm. So I'm going to get something like this. N is the number I'm starting with, and b is going to be my base. So I write n as b times q0 plus a0, where q is the quotient, a0 is my first remainder. Since a0 is a remainder, it's going to be greater than or equal to 0 and strictly less than b. In other words, it's going to be a digit in this base. So then we do another division, but now I divide b into this previous quotient. So I'm able to write q0 as b times q1, another quotient, plus a1, another remainder. And this remainder has to be less than b, greater than or equal to 0, so this is another digit. And then you just do this over and over and over and over. And this stops eventually. This process terminates when we get a quotient equal to 0. And it produces the base b digits of n from right to left. So I highlighted that, and I'm going to underline or circle the important parts. You stop when you obtain a quotient equal to 0, and you read the digits from right to left. Okay, that is, these remainders are going to be the digits in your new base, and you read them from right to left. So let's do an example. So we are going to convert the decimal number. We know it's decimal because there's a 10 right there. We're going to convert the decimal number 12,345 base 10 into base 8. So the first thing we do is we divide 8 into 1, 2, 3, 4, 5. So I'm going to do this first one, this first division. Actually, I think I might do all of these, do it in detail so you can see how it works. So just kind of bear with me. And you can fast forward the video if you don't want to watch all of the long divisions. But I want to show you each and every step for just this one example. So 8 will go into 12 one time. There's an 8. Subtract and get 4. Bring down the 3. 8 goes into 43, 5 times? So that's 40, bring down the 3, or subtract to get 3, bring down the 4. 8 goes into 34 4 times. So that's a 32, subtract, bring down the 5. 8 goes into 25 3 times. So 24, whoops, 24, and the difference is 1. So there's my remainder. So what have we got? We got that we can write 1, 2, 3, 4, 5 as 1543 times 8 plus 1. So we have that remainder right there. Okay, now we do another division. We do 8 into that previous quotient. So 8 into that quotient, 1543. 8 goes into 15 one time. And when I subtract, I will get 7. Bring down the 4. 8 goes into 74 9 times. Multiply and get 72. Subtract, bring down the 3. 8 goes into 23 2 times. So it's 16 and a 7 is my remainder. So now I write 1543 is equal to, my new quotient is 192 times my divisor plus my remainder now, the remainder this time was 7. and then we keep going with this. Now I'm going to divide 8 into 192. 8 goes into 19 2 times. It's 32. 8 goes into 32 4 times. 32 with a remainder of 0. Now, at this point, people get a little confused because they're thinking, oh, I stop when I get a 0. But you don't stop when you get a 0 remainder. You stop when you get a 0 quotient. So we actually don't stop yet. We're going to write 192 is equal to 24 times 8 plus 0. So we keep going with this, and we divide 8 into 24. 8 goes into 24 3 times with a remainder of 0. So 24 is equal to 3 times 8 plus 0. And now we have one more division. I have to divide 8 into 3. 8 goes into 3 0 times. There's a 0 quotient. It means this is our last step. 0 times 8 is 0 with a remainder of 3. So we get that 3 is equal to 0 times 8 plus 3. And again, we found that 0 quotient right there, which means that's our last step. And the digits right here are going to give us, those remainders are going to give us the digits for our octal representation. So now to find out what the expansion is. So we have 1, 2, 3, 4, 5, base 10 is equal to, remember I said you have to read it from right to left, or since I wrote them vertically, I read them from bottom to top. So this is going to be bottom to top. You always read it bottom to top. So the first digit is a 3, and then a 0, and a 0, a 7, and a 1, base 8. So 12,345 base 10 is equal to 30071 base 8. So again, this isn't anything that's really hard or weird. It's just doing repeated long division. You just have to keep track using the division algorithm. Keep track of all of your remainders and your quotients every time. And then at the end, once you get a 0 quotient, you read from the bottom up and get your digits for your octal representation.